So now we want to talk about the mass balance, in particular of glaciers. So what mass balance just talks about is that you want to think about the mass that's coming into and out of a system. And so we can apply this to any system that we want. Obviously here we're going to be talking about glaciers. And so we want to talk about the things like the inputs and the outputs. So the inputs to a glacier are the snow and the ice that fall. Maybe it's an avalanche of snow from a higher up on the mountain. There's various ways we can get material into a glacier. The outputs would be things mostly like melting, but also sublimation, like we discussed in the last video, as well as maybe calving of an iceberg, of a glacier. That's when the big parts break off into a body of water, typically the ocean. So we can have these inputs and outputs. If we think about their relative amounts, if we have inputs and outputs and we compare those two, so if we call this I and we call this O. So if inputs are greater than outputs for a glacier, well then the glacier is going to grow, expand. And the opposite is true, where inputs are less than the outputs, then the glacier is going to shrink. And so here we have our sketch of our valley glacier. And there it is. There it is. I can make my mountain a little bit bigger here. Okay, so if we have this as inputs being equal to outputs, if we draw another mountain range over here, and we draw this one as inputs greater than outputs, move the page over. And if I move it over here and I draw another mountain range where my inputs are less than outputs. So I have these three different scenarios. And just to be clear, that's my glacier sitting up there. So if this is our glacier moving down here and this is inputs being equal to outputs, this is kind of a stable formation. Take a second, pause the video and see and draw what happens to the size of that glacier if inputs are less than outputs, and what happens to the size of that glacier when inputs are greater than outputs. So pause it and come back in whenever you've got it, and we'll keep going. All right, so let's start with inputs greater than outputs. Well, if inputs less than outputs. If our inputs are less than our outputs over here, well, then we're losing it and we're shrinking our glacier. And so our glacier used to be this size over here, but maybe it's now gotten thinner and maybe it's moved up the mountain some. And so it's gone up there as well. So that's with inputs less than outputs, we're shrinking. Well, then it kind of makes logical sense that if we take our stable and now our inputs are greater, well, then our glacier is going to get bigger and maybe it extends farther down the mountain now. And so this ice is moving this way. And so we talk about this as glacial advances. And then we talk about this as glacial retreats. So this is the way we can move ice up and down. And the equilibrium line altitude would do the same thing. If this is an approximation for the ELA over here, the ELA is going to move down in this case where inputs are greater. So the ELA is shifted maybe down to here. And then in the other scenario, the ELA has gone up. Which of these three scenarios do you think most glaciers are in these days? Are we in the glacier retreats, the stable, or the advanced? Well, given what's happened to climate and how we have a generally warming planet, most of our glaciers are in this retreating phase. And so they are shrinking and the ELA is moving up the mountainside. So this is our mass balance for glaciers. Like I said, it also can apply to other systems. You could do this mass balance with inputs and outputs for lakes, for rivers, for other things, but here it is specific for glaciers. So we have our stable, retreating, and advancing for glaciers.